National Electrical Code, or NEC Article 210.23. A2 addresses permissible loads for branch circuits, specifically regarding dwelling units. A branch circuit is defined as the circuit conductors between the final overcurrent device protecting the circuit and the outlet or outlets. Article 210.23. Covers branch circuits rated 15 or 20 amps. Article 210.23. A1 discusses 15 and 20 amp branch circuits, stating that a 15 amp branch circuit can supply lighting units or other utilization equipment, or a combination of both. The rating of any one code and plug-connected utilization equipment must not exceed 80% of the branch circuit ampere rating. If the branch circuit supplies receptacles, cord and plug-connected equipment must not exceed the maximum cord and plug-connected load. Article 210.23. A2, which is most relevant, addresses branch circuits supplying lighting units or appliances. It states that in dwelling units, branch circuits must not supply other than the equipment identified in 210.23. A1, or receptacle outlet serving only the dwelling unit. This means that a circuit serving lighting or appliances within a dwelling unit should not also serve outlets outside of the specific dwelling unit. The NEC Handbook provides additional clarification and examples to aid in the application of this requirement. The purpose of this requirement is to ensure that lighting and appliances within a dwelling unit have a dedicated circuit, enhancing safety and reliability. By preventing the sharing of circuits between dwelling units and common areas, potential issues such as overloads or faults in one area affecting another are minimized. This enhances safety for occupants and reduces the risk of fire or electrical hazards. Firstly, understanding the specific language of NEC Article 210.23. A2 is important. The code clearly states that branch circuits and dwelling units should not supply other than the equipment identified in 210.23. A1, or receptacle outlet serving only that dwelling unit. This means that any circuit within a dwelling unit intended for lighting or appliances should not also serve outlets outside of the unit. Secondly, the NEC Handbook provides valuable insights into the intent and application of code requirements. The handbook often includes commentary, examples, and illustrations that help clarify complex code provisions. Consulting the NEC Handbook can provide a deeper understanding of the reasons behind Article 210.23. A2 and how it should be applied in various situations. Thirdly, there are several reasons why the NEC prohibits the sharing of branch circuits between dwelling units and common areas. One primary reason is to prevent overloads. If multiple dwelling units or common areas share a single circuit, the combined load could easily exceed the circuit's capacity, leading to trip breakers or even dangerous overheating of conductors. Another reason is to minimize the impact of faults. If a fault occurs on a shared circuit, it could affect multiple dwelling units or common areas, causing inconvenience and potential safety hazards. By isolating circuits within each dwelling unit, the impact of faults is contained, and the risk of widespread disruption is reduced. Fourthly, consider the practical implications of violating NEC Article 210.23. A2. In the scenario described, where hallway outlets are connected to the same circuit as outlets in a dwelling unit, the use of a vacuum cleaner in the hallway can cause the circuit breaker in the dwelling unit to trip. This is because the vacuum cleaner's load, combined with the existing load in the dwelling unit, exceeds the circuit's capacity. This situation is not only inconvenient but also potentially dangerous, as repeated overloading can damage the circuit components and increase the risk of fire. Fifthly, when addressing situations where electrical installations do not comply with NEC requirements, it is crucial to take a systematic approach. Begin by thoroughly reviewing the relevant code articles and any applicable interpretations or guidelines. This will help you gain a clear understanding of the specific requirements and their intent. Next, document the non-compliant condition, including photographs, measurements, and any other relevant information. This documentation will be valuable in communicating the issue to the responsible parties and in supporting any corrective actions that may be necessary. Then, communicate the issue to the appropriate individuals, such as the property owner, building manager, or electrical contractor. Explain the code requirements, the potential hazards associated with the non-compliance, and the recommended corrective actions. If necessary, consult with a qualified electrical inspector or engineer to obtain further guidance and support. Sixthly, the presence of arc fault circuit interrupters, or FSIs, adds another layer of complexity to the situation. FSIs are designed to detect and interrupt arc faults, which are dangerous electrical conditions that can lead to fires. While FSIs provide enhanced protection against arc faults, they can also be more sensitive to nuisance tripping, especially in older electrical systems or when used with certain types of equipment. In the scenario described, the use of a vacuum cleaner on a circuit protected by an FSI may cause the breaker to trip due to the presence of normal arcing associated with the vacuum cleaner's motor. This can be particularly problematic if the circuit is already heavily loaded or if the FSI is not properly matched to the load characteristics of the circuit. Seventh, it is important to verify that the FSIs installed are appropriate for the application and are functioning correctly. FSIs should be tested regularly to ensure that they are capable of detecting and interrupting arc faults. If nuisance tripping is a recurring issue, it may be necessary to evaluate the circuit and the FSIs to determine if any adjustments or replacements are needed. Eighth, the NEC contains specific requirements for the installation and use of FSIs. For example, NEC Article 210.12 specifies where FSI protection is required in dwelling units. Typically, FSIs are required for branch circuits supplying outlets in bedrooms, living rooms, dining rooms, family rooms, and other similar areas. Article 210.12 also includes exceptions and modifications to these requirements, so it is important to consult the latest edition of the NEC for the most up-to-date information. Ninth, consider the broader implications of electrical code compliance. Electrical codes are developed and maintained to ensure the safety of people and property. Compliance with these codes is not only a legal requirement but also a moral obligation. By adhering to electrical codes, electrical professionals can help prevent electrical hazards, reduce the risk of fires, and protect the lives of building occupants. 10th, electrical codes are constantly evolving to address new technologies, changing safety standards, and emerging hazards. It is important for electrical professionals to stay up to date on the latest code requirements and best practices. This can be achieved through continuing education courses, industry publications, and participation in professional organizations. By staying informed and engaged, electrical professionals can ensure that their work is safe, compliant, and of the highest quality. In conclusion, NEC Article 210.23 8.2 prohibits the sharing of branch circuits between dwelling units and common areas. This requirement is in place to enhance safety, prevent overloads, and minimize the impact of faults. When addressing situations where electrical installations do not comply with NEC requirements, it is important to take a systematic approach, including reviewing the code, documenting the non-compliance, communicating the issue to the responsible parties, and consulting with qualified professionals. By adhering to electrical codes and staying up to date on the latest requirements, electrical professionals can help ensure the safety of people and property.